Hello, welcome to this lab session, where we will be working on the customer churn prediction. In the current era, there are numerous businesses that companies run in their region. There are many telecom companies offering their services like calls, phone internet, PC internet, and landline features. Then there are certain banks, considering their purpose is the same, depositing your money, but each bank has different services to offer. With the era of online services evolution, e-transportation has played a vital role in this. There are different online transportation services. Again, their purpose is the same, to move people among different cities, but their services and features are different. The type of proximate experience that the customer is given by any of the service companies, including the innovation in their services with the evolution of new technologies, given an ultimate experience to the customers and makes them happy. And this being the reason that the customer is a long-term client of the company, enjoying the perks in addition to the services he pays for. As long as the companies execute strategies and the customer is happy, there exists a long-term relation between the two. But when this is not the case, the customer or the client leaves that company and joins a new one providing the same services with more features. This is what the churn prediction is all about. We will be looking at a use case for the telecom company which offers a number of telecom services like the phone service, internet service with online security, online backup, device protection, technical support, and many others. The dataset provided to us has a variety of information that contains info about the services that customer has purchased, their gender information, tenure with the company, their monthly charges along with payment method, and much more that we will see while performing the practical. Using the provided information, we will apply deep learning techniques to predict whether the customer will leave the telecom company or will remain a loyal customer. For this purpose, we will be using the Jupyter Lab and the deep learning library Keras. Let's move on to the practical for this use case. Hello and welcome to this lab session, where we will look at the practical approach towards solving the churn prediction problem with the help of deep learning using the Keras library. Here I have listed a series of steps that we will perform for the churn prediction. We will begin with importing the dataset, moving on with the data cleaning, the famous exploratory data analysis steps where we will visualize the impact of different dataset features on the churn prediction for the customers. Then we will perform some data pre-processing prior to the model building and evaluation. First, let me import the necessary libraries required. So here I am importing the pandas library, NumPy, and the matplotlib. I have commented line number 7, 8, and 9 that I will uncomment later and let you know why to use them. Let's run it. Now moving on to the first step for importing the dataset. I have this dataset in a CSV file for this stated problem, and here you can see this CSV file I have opened for you in the Excel. We have all the features listed down here, and in the end it is the value for the customer that either he or she will leave the company or not. Basically the churn output. Now using the pd.read_csv command, here I am importing the CSV file from my local directory, and then I will view a few samples in my df variable. So here we get the 5 random rows as output of our actual dataset. So you can see we have the customer ID, the gender, citizen, either they are senior ones or not, and all other features as well. And at the end is the value for customer churn. If you notice here that we have some missing columns that the output does not show to us. And this is because of the limitation of the pandas library. So for that I will go back to the first cell here and I will uncomment these lines 7, 8, and 9. So this will now display all the columns in the dataset. Let's run it again. And now you can see that it shows you all the columns in the dataset. Now we are done importing, and let's move to the data cleaning process, which we will see in our next lab session. Hello and welcome to this lab session. In this session, we will go through the data cleaning steps for this dataset. First, we will look at the shape of the dataset. So we have 7,043 rows and 21 columns. Let's have a look at the data types for the features we have in our dataset. So you can see that we have some object types, some numeric values with int64 and float64 data types as well. One thing you will notice here is that here are the monthly charges, which are of float64 type. Instead, the total charges should also be numeric, but it's of object type, which is of concern to us. Let's have a look at the values of this column. Okay, so these are all numeric values inside, but the data type is a string. As you can see these single quotes here, I will convert them to the numeric type using the pd.numeric function. Now run this line. So there seems to be some empty or blank spaces in our values for the total charges. That's why it has prompted this error. So to ignore this error and to process the non-empty values, we use the argument error equals to Keras. With this, it will convert all the values to numeric data type. You can see that now the values are converted to float64 type. Let's also see the empty values in the dataset. So for this, if we give this complete code as an index to the df variable, it will return the rows that have null values for the total charges. So here we can see that these rows have empty values. And let me just scroll ahead for you. Here you go. The empty values can be seen for the total charges column. Now to check the number of total rows that have null values for the total charges features, we simply use the dot shape command. And we have 11 rows as null values. So to keep our dataset clean and error-free for the model to be trained, we will drop these values. So here I'm dropping the values that have null values in the total charges column and storing the updated dataset with dropped values in the variable df1. Previously, if you remember, we had 7,043 rows. Now we are left with 7,032 rows. As we have made a new variable df1, so we now convert the values in there for the total charges to numeric type. And this time it gives no error. So we will copy these converted values into the total charges column in the df1 variable. Now, if we look at the values for this variable, you can see that we have all the values as numeric data types. Also, to ensure, let's check the data type as well. So here we have the data type for the total charges as float64. Also, I will remove the customer ID column from the dataset as it has nothing to do with the model to be trained. And here we have the dataset with these all features. So finally, now the shape of our dataset is 7,032 rows and 20 columns. This is all the cleaning we had to do. In our next lab session, we will look at the exploratory data analysis for this dataset. Hello, welcome to this lab session where we will look at the very important step before you train any of your deep learning or machine learning models, which is the EDA. This gives you a detailed insight and understanding of the dataset you are to deal with. So at first, these are the self-exploratory functions that I have created here, and each one of them is for a different type of plot. So I have a function for the pie plot, bar plot, histogram plot, and the histogram subplot. Let's define them so that we can use them whenever we want while performing the EDA. Leave the cell, or if you don't have these libraries installed, you can uncomment them and install them one by one. Now here I will import the Plotly and Seaborn libraries. Now let's start with the client churn distribution. So the dataset pie plot tells us that according to the dataset we have, 26.6% of the customers can leave the telecom services, while the rest 73.4% will continue their services with the company. The customer's decision on whether to leave the telecom company or not depends on a number of things. The major factor is the quality and the type of services that the company provides to the customer and the level of ease of access the customer has to the services. We will explore each one of them for the features we have in our dataset. And here is the histogram plot for the customer's churn with respect to their tenure with the company. The tenure value is in months, and this graph shows that the majority of the customer, that is more than 900, having a tenure of about 70 months and will remain with the same company and won't leave. While for the less tenure, there are around 50-50 ratio of the customers leaving as well as not leaving. And in between, we can see the most of the customers with less tenure have a higher chance of leaving the telecom company. If we look at the box plot, the customer that will not churn are the ones that have high tenure, while the ones who have less tenure, like you may say less than 30 months, have a probability to quit their services, with a note that there are a few outliers here as well. Next, let's have a look at the histogram for the customer churn with respect to the monthly charges they are paying. So here we have the histogram which shows that customer with less monthly charges are not leaving, whereas for the customer with higher monthly charges have higher chances of leaving. And a clear picture for this can be seen in the box plot as well. Now let's move on to the contract type analysis. So we have three different types of contracts for the customer in our dataset, and this is why here we are plotting the three different pie charts for each one of them. We can see here that we have a high rate of customer churn for the customer where the contract is on a month-to-month basis, whereas this percentage is less for the customer having a 1-year contract. And then the customers having a 2-year contract have a very less rate of leaving the telecom service company. This means that the customers on a long-term contract have less probability to churn. Next, let's analyze the monthly charges impact on customer churn rate. And here we can see that the customers having to pay lower monthly charges have less probability of leaving the company as compared to the customers who are paying higher charges. Let's come on to an interesting analysis based on gender and how it will impact the churn rate. And it is quite interesting to note that the churn rate for both the genders are almost same, around 27%. So it means that the churn rate has less impact on gender in our dataset. You can perform some more interesting data analysis on this. Let me perform a last one, and here we will see the impact on churn rate based on the customers who also have their dependents using the same telecom service. So we have two graphs here, one for the dependents and the other one for no dependents. We can see that the customers having no dependents have a higher churn rate as compared to the ones having their dependents using the same service. This may be because the company might offer a package or so for the family and friends number or so on. Or maybe the calling rates to such dependents might be low, or it can be any reason that is not known to us. So what we see is that the churn rate for the customer with no dependents is very high. Alright, this is it for the EDA part on this dataset. In our next lab session, we will perform some data pre-processing and then we will start the model training. Hello, welcome to this lab session. In this session, we will look at some data pre-processing or the dataset. The important thing is to convert all the non-numeric values to numeric ones so that we have a complete numeric dataset for the model training phase. Here I have created a function that is responsible to search and print all the unique values in each column that is of object data type only. Let's use this function on our data frame df1. Okay, so here you can see that the column gender has two values, female and male. Likewise, we can see the multiple lines column have three different values, no phone service, no, and yes. Similarly, for all the columns, we can see the unique values it has. And if you notice, there is no internet service, no, and yes, both in online security and other columns as well, but both means the same. And in the same way, we have the no phone service and no, both in multiple lines, both of which means the same. So we can simply replace them with a no so that we are left with two values, yes and no only. And that makes our model training process easier as well. So I will replace these values with no, and let's run it. And then we'll see the unique values. And here it can be seen that now we only have two values, yes and no. The internet service has three values, and the contract has three values. And for the payment method also we have three values. Now we are okay, and let's proceed next. Now I will replace 1 with yes and 0 with no for all the columns that have a yes and no value. And for that I have this yes no column variable here in which I have stored all the variable names. Let's run this cell. And now I will print all the unique values for all the columns, excluding the object type restriction we used previously here. So all our yes no values are now replaced with 1 and 0. And for the gender, that is male and female, we will convert it to 0 and 1 for male and female respectively. Let's run this. And now for our remaining columns that still have the object values, we will use the one-hot encoding scheme. What this will do is create three different feature variables for the unique values it contains. For example, if I go above, here you can see we have contract type as month to month, 1 year and 2 year. And after applying the one-hot encoding scheme, this will create three different variables with these three different types. And the raw which contains the actual value out of these will be a 1 and the other two will be 0. Now let's run this cell, and here I will see some samples. And here if I scroll onto the right, here you can see that we have three columns for contract. The contract month to month, the contract 1 year, the contract 2 year. Same is the case for internet service and payment method. Now if we look at the df2 data type, data types for this df2 data frame, it can be seen that now we have all the values in numeric format. Now all the values we have are in the range from 0 to 1 except for the tenure, monthly charges and total charges. Now to convert these features values in the range 0 to 1, we use the scikit-learn library known as max-min scaler. Now let's run this cell, and now we can see that all the values are in range from 0 to 1. Now we will split the dataset into test and train data using the scikit-learn library. The churn column is our output, so everything except this column is X, and the churn column is our output, and now it is stored in variable Y. The shape of the X training set is 5625 rows and 26 column, and for the X test we have 1407 rows and 26 columns. Let's see the 10 samples from our X train set. And here are the samples from our training set from which our model will be trained. And the length of our X-train column is 26, which means we have 26 features on which our model will be trained. So our data is prepared and ready for building the model. And in our next lab session, we will continue with the model training process and its evaluation. Hello, welcome to this lab session. In this session, we will look at the model training process with the help of the deep learning library Keras. So the first thing I will do is import the TensorFlow and from that import the Keras module. Using the knowledge we gained in the theory session for this course, I will use the deep learning model for this project as can be seen here. So we have 26 input features as seen previously, and using a second layer of 26 neurons and the activation function as ReLU, we will create a third layer that will contain 15 neurons with the same function ReLU, converging to a single output layer with an activation function of sigmoid. Now let's create this multi-layer perceptron model for binary classification with the help of Keras library. Using the keras.sequential function, we will declare this model, and here in line number 3, we are declaring the second layer of our model. The first argument here is the number of inputs of our dataset. The 26 here in the input shape argument is the number of neurons for the second layer, while the activation function is declared as the third argument, which is the ReLU function, as can also be seen in the diagram here. Now in the next line, the line number 4, we declare the third layer with 15 neurons having the activation function again as ReLU. Then in the next line, we have the output neuron, which uses the activation function as sigmoid. Now let's have a look at the compilation parameters we are using. And there are many optimizers that can be used while compiling the model. You can use Eta Delta, FTRL, stochastic gradient descent, or ADAMS. I have adams ADAMS optimizer, which is an extension to stochastic gradient descent. It is pretty much straightforward to implement, computationally efficient, and requires less memory. Alright, then we have the loss argument. The one I'm using is the binary cross entropy, and it computes the cross entropy loss between true labels and the predicted labels. Then is the matrix, and this is what is used to judge the performance of your model. So here we have used accuracy as the parameter. Finally, we will train the model with the model.fit function, and I will run the model to train for 100 epochs. Let's execute it to train the model. Here it is. Now training the model, and we can also see that the accuracy is increasing at each epoch, whereas the loss is decreasing. Okay, so the model is now trained. Let's evaluate the model. First, we are looking at the model summary that we just created. So here we have 3 dense layers with 26, 15, and 1 neurons respectively. One thing of noticeable consideration here is that if you look at the predicted output, here I have displayed 5 samples and the values are of float data type, but in binary classification we have either 1 or a 0. So what we will do here is that for the predicted values, the value that is greater than 0.5 will be replaced by 1, and the value that is less than 0.5 will be replaced by a 0. Now let's see the values again. So here you can see that the predicted values are now as zeros and ones. Now in the next cell, I will display the same first 10 y-test values. It can be seen that our model predicted the values of the first one as 0, which is correct, and the second one as 0, which is not correct because here it is given 1. And the third predicted value is also 1, but in actual it is 0. Then the next predicted value is 1, which is correct, and so on. We have a series of values of churn and not churn customers. If we look at the accuracy, precision, and recall, here I'm calculating them using the sklearn library. So the classification report function will calculate the accuracy, precision, recall, and F1 score. And here it is. It can be seen that the accuracy for our model is 78%, while the precision for not churn customers is 84%. And the churned customer precision is 63%. And then there are values for the recall and F1 scores for both the cases. One of the important analysis is the confusion matrix. It tells us about the performance of the model. So here in this cell, I'm creating the confusion matrix. Let's run it. Here are the values to best compare it. I have here the labeled confusion matrix, with the help of which we will understand this confusion matrix. Let's start with the generated confusion matrix. Here the x-axis shows the predicted values and the y-axis represents the truth, or you may call it as the actual values that reside in the dataset. The 0 here represents that the customer did not churn, and the 1 represents that the customer did churn. So there were 167 such values that were wrongly predicted as not churned customers, while in actual they were the churned customer. It is also known as the false positive value. And 855 here represents the correct values, meaning that these were the correct predictions made by the model regarding the customers who did not churn. And this is also known as the true positive values. Moving on further, in the next value of the diagonal here, 241 here represents the correct predictions regarding the churn customers, also known as true negative. And the value 144 here represents the wrong predictions, which actually predicted that these many customers churned, while in actual they did not churn. And it is also known as the false negative value. The values in the diagonal here are always correct predictions. Let me show you how to calculate the accuracy, precision, and recall using the values in the confusion matrix we just generated. First, let's look at the shape of the y-test dataset. So we have a total of 1,407 values. Now, in the confusion matrix values, the values are stored in the variable name CM. And here I have created separate variables for each matrix index. For the true positive value, the false negative, false positive, and the true negative. And the total prediction is the sum of all the 4 quadrant values. And it must be equal to the y-test shape value, as the predictions are made on the test dataset of size 1,407. So let's run it. And here we can see the value for the total prediction, which is 1,407. As mentioned earlier, the diagonals contain the correct prediction. So summing them up and dividing by the total number of predictions done will give us the accuracy for the model. So here we are summing up the true positive and the true negative and dividing by total prediction. Let's run it. And it gives us 0.78, which is the same as can be seen here for the value of accuracy. Now let me show you the precision and recall for both the cases for churn and not churn. We have already seen it in detail in our theory session. Now let's calculate them here with the help of the confusion matrix. First, we calculate the value of precision of not churned customer. This can be calculated with the formula as stated here, and the true positive divided by here sum of the true positive and false positive, This is because the positive in our case represents the customer who did not churn. So the value comes out to be 0.84, which is the same as seen above here. You can also calculate the other values as per the formulas stated here in these cells. I will leave that as an activity for you and you can explore them on your own. Finally, let's have a look at the graphs for the accuracy and loss while training the model at each epoch. So these lines of code in this cell will graph the accuracy and the loss plot for the model. Now here it can be seen that with each epoch the model accuracy is increasing and in second plot the loss decreases. But you won't get the accuracy greater than 0.84 as you will enter into the saturation region. You can try this while training the model with 200 epochs. What you will notice is a straight line with some ups and downs in them trying to stabilize at the value close to 0.84. Alright, so this is it for this lab session. I hope you have got a clear understanding on how to train a deep learning model and calculate the model accuracy, precision and recall. The model actually predicted the churn rate of the telecom customers with the provided input features. Do comment below and let us know your experience in deep learning model training and how the efficiency for this model can be improved. Thanks for watching. See you in the next video.